In lesson 12.4, making predictions with experimental probabilities, we're going to continue and finish up on our 7.SP.6 standard. The essential question is how do you make predictions using experimental probabilities? And pretty much in this lesson, we're just going to use the tools that we've previously learned, not only in 12.1, 12.2, 12.3, but also in our ratios and proportions when we're looking at proportional relationships. So here we're going to use experimental probabilities to make a prediction, and we have an example here. Dana found that the experimental probability of her making a bullseye when throwing darts is 2/10 or 20%. Out of 75 throws, about how many bullseyes could she predict she would make? So I highlighted the important information, and we're going to set this up as a ratio, okay? So we have our percentage, and it's a 2/10 right here, and then we're doing 75 throws, and she wants to know about how much. So the X represents the how much. So if you remember when we did proportional relationships, we were talking about that scale factor. How many times does 10 go into 75? And the way that you can find that out, it's not an even number. It's not like saying 8 and 2 goes into 8 and that's 4 times. So what we have to do is we can take 75 divided by 10, and that's going to equal the 7.5. So we multiply the 10 times the 7.5, and our little saying, what we do on the bottom, we do on the top. So we take our 2 times 7.5, and we get 15. So she can expect to make about 15 throws out of 75 as bullseye. A second way that they show is using percentage. So they take the 2/10, and of course that's going to equal 20%, and we turn that into a decimal, so it becomes 0.20, and we multiply that by 75 and we get 15. So we come up with the same number here. When you look at the your turn, number 1, a car rental sells accident insurance to 24% of its customers. Out of 550 customers, about how many customers are predicted to purchase insurance. So of course we highlight the important information. We have 24%, we have out of 550 customers, and then about how many. So which method would you use? Would you use method 1 or would you use method 2? We're going to continue on using experimental probability to make a qualitative prediction. The important thing is with a qualitative prediction, it helps you decide which situation is more likely to occur, okay? So that goes back to our work that we did in 12.1 when we're looking at that scale of impossible to certain that we're talking about here. So in reading example 2, a doctor's office records data and concludes that on average 11% of the patients can call to reschedule their appointments per week. The office manager predicts that 23 appointments will be rescheduled out of 240 total appointments during the week. Explain whether the prediction is reasonable, okay? So we have to do the work, and then we need to do an explanation about it. So using the first method, that proportion, the proportional relationship we talked about, 11% is 11 out of 100, okay? So that's how they came up with this here. And then they set that up to about how many out of 240. So here we have to do our scaling. So we're going to take the 240 divided by 100. And that's going to equal the 2.4. So what we do on the bottom, because you multiplied 100 times 2.4 to get this, what we do on the bottom, we have to do on the top. So they take 11 times 2.4, and we get 26.4. So 26.4 is the average number of patients that would call to reschedule. Question over here in the math talk says, does it make sense though to have 26.4 customers? So what are you going to do with that? The second method, again, is using the percentage. We take the 11%, we convert that to a decimal, okay? You should know how to do that by now. If not, come see me, I'll help you out. And we multiply that by 240, and again, we get the 26.4 customers. So the prediction of 23 is reasonable, but a little low, because 23 is a little less than 26.4. So we're doing that comparison here of what the prediction was up here at 23 appointments. So here in the second year turn, in emails to monthly readers of a newsletter, 3% of the emails come back undelivered. The editor predicts that if he needs to send out 12,372 emails, he will receive 437 emails for undelivered emails. Do you agree with this prediction? So following the example 2, what you came up with, you can use one of those methods, method 1 or method 2, and then you're going to come out with what is 3% of 12,372, and then you're going to do a comparison to the 437 notices, and then do you agree with his prediction? So here in making a quantitative prediction, we're going to again use our quantitative, which is numbers, to compare options in the real world situations. So we have an online poll for a movie site shows its polling results for a new movie. So that's right here, this graph. If a newspaper surveys 150 people leaving the movie, how many people can it predict will like the movie based on the online poll? Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? We're going through our steps here, and we're going to analyze the information. The answer is a prediction of how many people out of 150 will like the movie based on the online poll. So you're doing that comparison of how many people from the poll, the online poll, and then predicting how many people that you physically talk to and that they like the movie. Also tell whether the 104 people that say they like the movie is enough to support the movie site's claim. So we already highlighted the important information before, but they have it written down here. The online poll says 72% of the moviegoers like the new movie, and the newspaper surveyed 150 people. So now we're going to go ahead and use proportions to calculate what is 72% of the people that surveyed. So we go through and you see the proportional relationship is set up again, and we have 72%. They converted that into a fraction, okay, because it's 72 over 100, and that equals how many out of 150. So we do, that's our scaling. You know, they take the 150 divided by 100, and that comes up with the 1.5. What we do on the bottom, we do on the top. So you take 72 times 100, or 72 times 1.5, and you get 108. So the newspaper predicts 108 people out of 150 say they'll like the movie based on the online poll. So here's where we have to do our comparison. Is 108 fairly close to 104? I think it is, so I think the survey could be pretty accurate. So here in your turn number 3, on average, 24% of the customers who buy shoes in a particular store buy 2 or more pairs. One weekend, 350 customers purchase shoes. How many can be predicted to buy 2 or more pairs? So we're looking at that 24%. If 104 customers buy more than 2 pairs, did more customers than normal buy 2 or more pairs? So of course we highlight our important information, 24%, 350 customers, how many, and the 107. So you would set that up like in method 1 or method 2 in the previous examples and go through the calculations. Here's another thing I'll point out to you. 24% is very close to 25% or 1/4 of the customers. So you could even go one step further and estimate what is 1/4 of 350 customers, and then do a comparison against the 107 customers. Below you have the guided practice. If you have any other questions, let me know and I'll help you out. Have a good day.